Welcome back, guys. In this particular session in the water playlist, we will be talking about the quality of the water, right? So what are the parameters which are actually assessing the quality of the water, right? So we'll be talking about the several parameters about the water quality, right? And this is very important chapter, guys, because here you can expect at least 1 to 2 MCQs for your particular exam, right? So basically, I'll be talking about 3 parameters of the water quality, but the main important parameter where the examiners are actually asking us questions, that is the chemical parameter. And in this chemical parameter, I shall be talking about the chlorination of the water, and this is very important, right? So let's begin with the parameters of the water quality, guys. So as you can see that we are actually having 3 important parameters as far as water quality is concerned. One is the physical parameter, then there is a chemical parameter, and then the biological parameter, right? So now let me take over to the very first one, that is the physical parameter, right? In the physical parameter, we shall talk about many factors, but very important ones I'm discussing over here, that we shall talk about the color, right? We shall talk about the color of the water, obviously. So the color, what about the color of the water, guys? Color of the water, it should not be having some kind of impurity. It should not be having some kind of color, right? We are saying that usually it is transparent color, right? So basically you can see throughout the water, right? So basically if it is having some kind of color, then that means obviously it is already infected. And they are saying that the permissible, the color is actually measured, color of the water is actually measured in some unit, and that unit is the true color units. So they are saying that permissible level for the color of the water is less than 15 true color units, right? So they are saying that if it is less than 15 true color units, what is it, TCU? True color units. Okay, if it is less than 15 true color units, then it is permissible. But ideally, guys, then it is permissible, right? But if you talk about ideally, right, then it should be less than 5 true color units, right? That is the ideal situation. That should be ideally, right? So after the color, we shall be talking about the order. What about the order of the water, right? So obviously the water should be odorless, right? It should not be having some kind of smell from it. If it is there, then obviously it is contaminated or infected by something, right? So order, if you talk about, it should be odorless. So it's very simple, nothing new over here. Okay, everybody knows that. And the next component in the physical parameter of the water quality is the turbidity, right? Turbidity. And if we talk about the turbidity, right, likewise in the color section, I told you that there is one unit which is actually determining or defining the rate of color basically in the water quality parameter. And here also I'm going to talk about one particular unit over here, and that unit is basically naphthometric turbidity unit, right? So basically they are saying that usually there should be no turbidity in the water, right? So there should be no visible turbidity. Okay, there should be no visible turbidity, obviously, and if it is there, then obviously it is contaminated, right? So it is not suitable for the drinking purpose, right? But they are saying that what is the permissible value? They are saying that if it is less than 1 naphthometric turbidity unit, right, then it is good for the household drinking water. So for the household drinking water, it should be less than 1 naphthometric turbidity unit. What is NTU? NTU is the naphthometric turbidity unit. Okay, so that is the case. If it is less than 1, then it is suitable for the drinking water, right? So for the household purpose, we can say over here that it is suitable for drinking water. Okay, so that is the thing over here. Now they are saying 2 more values, right? And usually in the exams they are asking us these threshold values over here, that they are saying if it is at what particular unit we can say, as far as turbidity is concerned, at what particular unit we can say that cloudiness of the water will be seen to the naked eyes. Then they are saying if it is more than 4 naphthometric turbidity unit, then the cloudiness of the water can be seen by the naked eyes, and if it is less than 4, then it can be measured by the instrument, but the cloudiness will not be seen by the eyes, right? Obviously, if the water is infected, right, you can see the turbidity over there in the water. If you can see the turbidity in the water, then obviously it is very much infected. Sometimes what happens is, you can't see anything in the water. It would be clear to you, but still it might be having some kind of turbidity, right? So if it is less than 4, if it is less than 4 turbidity, if it is less than 4 NTU, that is naphthometric turbidity unit, then you need to have some kind of instrument to measure that, right? Cloudiness will be not seen by the naked eyes. If it is more than 4 NTU, then it is that much infected that it can be seen by the naked eyes as well. So they are seeing two important values over here. These are the threshold values, or you can say the cutoff limits for the turbidity over here. They are saying that if it might be 4 NTU, less than 4, or more than 4 NTU. If it is less than 4, let's say, then the cloudiness of water can be seen by naked eyes. Can be seen by naked eyes. And if it is more than 4, then it can be measured by the instrument. Can be measured by the instruments, right? So be very clear with that. These values might be asked, so that's why I'm highlighting them as well. So less than 4 and the more than 4, and usually less than 1 NTU is suitable for the drinking water. However, the cloudiness will be seen after 4 NTU, but still, if it is 2 or 3 also, still it is not suitable for drinking, because obviously it is having the turbidity, just that you can't see that with the naked eyes. You need to have some kind of instrument for measuring that, right? So once we have talked about the physical parameters, guys, these are the main important physical parameters, that we are having the color, we are having the odor, and we are having the turbidity. Once we are clear with that, we shall move on to the chemical parameters, guys. In the chemical parameters, simply we shall say, I will be very simple over here. In the chemical parameter, I need to talk about the detail over here, right? So chemical parameters will be having so many factors, but we will be focusing ourselves onto the very, very important ones where the examiners are very focused upon. So over here we shall say that one could be the chlorination. We will be talking about the chlorination in detail, right? Another one could be the hardness of the water. We'll be talking about that. We are having two kinds of hardness, temporary and the permanent hardness. We'll be talking about that as well. And other parameters might be there, right? Some other parameters of the chemical parameters might be there, right? Okay. So now I'm moving on to the very important one, guys. First one, that is the chlorination part, right? So let's move on to the chlorination part, guys. So let's talk about the chlorination of water, right? Okay. Basically, it is very widely used for large purpose purification of the water. For large scale purification of the water, we are using the chlorination method, right? So it is used for large scale purification of water. Okay. Here next question comes, once they had asked us that it is actually, which of the following is the true statement regarding the chlorination of water. That was the question basically, and 4 statements were given, and one of those statements were, the chlorination is helpful in killing the bacteria, viruses, spores, everything. No, it's not the case, right? So that is actually the false statement regarding this particular thing, right? So here what I want to address, that in the chlorination, we are saying that it might be killing the bacteria. Yes, it is killing the bacteria in actual data. It might be killing the viruses as well. It may be killing the viruses as well, but it is not the sporicidal. It is not killing the spores. So that is a very important point over here. That needs to be remembered, that it is actually bactericidal. Okay. It might be virucidal as well. It might be killing, it is moderately virucidal. It is moderately virucidal, right? But not sporicidal. It is not killing the spores, right? So that is also the MCQ. Third MCQ, which shall be asked over here, that, what is the purpose of ionization? The purpose is to clean the water. And the thing is that how is it able to clean the water actually? So I will be talking about other details, but the thing is overall that it is actually having the oxidizing capability. it oxidizes the iron, manganese and the hydrogen sulfide, right? It oxidizes the iron, it oxidizes the manganese, right, and the hydrogen sulfide, right, and the hydrogen sulfide. Okay, then if you talk about how the mechanism of action, the chlorine, if I'm saying the chlorination of water, basically what I will be doing, that whatever source I need to chlorinate, I will take the water from that source. For example, that river is there. Okay, I am taking the water from this particular river, or I need to chlorinate the swimming pool, let's say. So I will be taking the water from that source, I will be taking the water from the swimming pool. So basically then I will be adding the chlorine to it. That is simply what is chlorination of water. Chlorination of water means that I will be adding the chlorine to the water. Adding the chlorine to the water will be called as the chlorination of the water. Simple. Next point over here is that how the things are happening by the adding of the chlorine to the water. What are things are happening and what compounds are forming in actual, and how they are actually doing the chlorination. So look over here, guys. Usually what happens is, let's say, so we are talking about the mechanism of action of chlorine, that how the chlorine is actually killing the bacteria over there. So guys, basically usually what is happening, you added the chlorine in the water. After the addition of chlorine in the water, the chlorination will happen. Actually what happens is that there will be the formation of hydrochloric acid with that HOCl. This HOCl is the hypochlorous acid. Hypochlorous acid, right? Once this hypochlorous acid will be formed, then what will happen, guys? HOCl, this is the hypochlorous acid, right? Now what will happen? It will be forming the hydrogen and OCl. It can be actually break down into these things. So OCl, this OCl which you are seeing right now, this will be called as the hypochlorite ion. This will be called as the hypochlorite ion, right? Hypochlorous acid is the HOCl and OCl is the hypochlorite ion, right? Which are the following, among the hypochlorous. So we saw two things over here. There is a formation of the hypochlorous acid and there is a formation of the hypochlorite ion. Both of these things, that hypochlorous acid and the hypochlorite ion, both of these things are helpful in the chlorination of the water. Both of them will serve the purpose. But which of the following is very important? The hypochlorous acid is 70 to 80% more effective as compared to the hypochlorite ion, right? So if you talk about over here, that I shall write that HOCl is more effective as compared to OCl, right? How much effective it is? It is around 70 to 80% more effective as compared to hypochlorous acid, more effective as compared to hypochlorite ion, right? The next point over here is if you talk about the disinfection of the water by the chlorine, right? It is actually happening by the help of what? Hypochlorous acid or hypochlorite ion, by both of them. But we are saying more effective, which one is more effective? That is also the MCQ. That is your hypochlorous acid is more effective as compared to hypochlorite ion, right? At what point of pH? Once they asked us that at what point of pH the chlorination of water is seen, okay, or it will be happening more suitably. So at the pH of around 7, right? At the pH of around 7, that is the neutral pH. At the pH of around 7, we are seeing that the action of the chlorine, right? Action of the chlorine is very much adequate. So at what point of time, if they are asking us, then we can say that chlorine acts best in water at pH of around 7. Okay, so please be very clear with that. Now we shall talk about some of the principles of the chlorination, right? Some of the principles of chlorination, right? And here the very first term which we shall talk about, that is what is chlorine demand, right? What is chlorine demand? Okay, we should understand that what is chlorine demand. Chlorine demand, basically they are saying that chlorine demand. I'm saying the chlorine demand of water, right? So after this, I'll be talking about a very important concept, guys. So listen to me very, very attentively over here. What is the chlorine demand of water? It is that difference between the amount of chlorine I'm adding to the water. This is the chlorine, guys. This is the water. So this is the difference. This chlorine demand of water, what it is saying basically, the difference between the amount of chlorine which will be added to the water and amount of residual chlorine which will be remaining at the end of the specific period of contact. I am saying that let's say this is the water, in the glass, right? There is a water. Okay, I will be adding the chlorine to it. I will be adding the chlorine to this water, right? So what amount of chlorine I will be adding, right? What amount of chlorine? This is actually the difference. This is actually the difference between the amount of chlorine which needs to be added to the water and the residual chlorine which will be left after a contact period of time, right? So basically, before that, let me actually explain you about this chlorination of the water in a detail, right? So look at this particular diagram, guys. After that, you will be able to understand this. So look over here. Here, what I can see, this kind of graph over here. On one side, you can see that there is a chlorine residual, right? And in this side, you can see the chlorine quantity, right, in parts per million. So what you are seeing basically here, that first the graph is going like this in the up direction, right? And then the graph is coming down. And then again it is going up, right? So what is happening over here? Basically, it's nothing. You can see that at this point of time, in this particular area, what I'm doing, I'm adding the chlorine to the water. I'm adding the chlorine to the water for the chlorination purpose. What will happen, guys? Hypochlorous ion and hypochlorite ions will be formed, which is more effective. Hypochlorous ions are more effective. Here, what will happen? The chloramine formation will start. What is the chloramine formation? Chloramine formation simply means that, in the water, there could be some kind of microorganisms, right? Those microorganisms will be actually, their fecal matter or their excreta will be actually producing the ammonia. So the chlorine which you are adding to the water, it will be actually binding with the ammonia, right? So the chlorine which you are adding in the water is already having the microorganism which will be producing the ammonia. So water itself is having the ammonia. You are adding the chlorine to it. Chlorine and ammonia will bind together, right? And that's how the chloramine will form. Simple. So chloramine is nothing but the binding of chlorine with the ammonia, right, in the water. So chloramines have some disinfection ability. So at this point of time, there is a formation of chloramines, right? Formation of chloramines. Formation of chloramines means what? Formation of chloramines simply saying that the chlorine is actually binding with the ammonia, right? Chlorine is binding with the ammonia. Now what will happen after that? Once the chloramine, they will be binding it. Now chlorine will start destroying the chloramine. I mean the chlorine, it was binding to the ammonia, right? Now it will start destroying these chloramines. So chloramine formed. Now the chlorine, you are keep on adding the, chlorine to the water. Now what will happen? This excess amount of chlorine will start destroying this chloramine. So first of all, what happened? There was formation of chloramine. Then after that, there will be the destruction of chloramine because you are keep on adding the chlorine to it. So first of all, initially when you will be adding the chlorine to the water, it will be keep on making the chloramine. It will be keep on binding to the ammonia. At one point of time, the ammonia will be finished, right? At one point of time, there is no more ammonia. Now you are still adding the chlorine to the water. Then what will happen? It will destroy the chlorine. The excess amount of chlorine which you are adding, it will start destroying that chloramine. So that's why you are seeing that graph is actually coming down again. And then a very important phenomena comes. That is breakpoint. And that is also called as a breakpoint of chlorination, right? So here now we shall say at this point of time, this is called as the breakpoint of the chlorination, right? In the breakpoint of the chlorination, what will be happening basically, the destruction of the chloramine will be happening. After that, once the breakpoint will be coming, right? After the destruction of the chloramine, breakpoint comes. Once the breakpoint will be coming, there will be the formation of free residual chlorine. There might be the formation of, free residual chlorine, right? There might be the formation of total chlorine residual. There might be the formation of combined residual chlorine. Actually, listen to me very carefully. Here, two things are happening. There is a formation of free chlorine residual and there is a formation of combined chlorine residual. The total of that is called as the total chlorine residual. Okay, so after the breakpoint, these products are actually getting formed, right? So building of free chlorine residual and the combined chlorine will be called as the total chlorine residual. So what I told you in this particular graph, first of all, I told you that once you are adding the chlorine to the water, it will be forming the chloramines. After that, what will happen? Excess amount of chlorine will lead to the destruction of these chloramines. What was chloramine? Chloramine was simply binding of the chlorine with the ammonia from the microorganism in the water, right? So formation of chloramine, destruction of chloramine, and then the breakpoint comes where the chloramine have been destroyed completely. The breakpoint will come, then the free chlorine will be present and the combined chlorine will be present. Okay, there is a test which can be actually used to estimate these total and free chloramine. Also, we'll talk about total and free chlorine in the water. Also, we'll talk about them. But for now, you just understand after the breakpoint, these free chlorine and the combined chlorine, total chlorine will be present over there. I will come to the breakpoint, okay, after a few minutes as well. But that was the story of the breakpoint chlorination. Very important for the exam. So when the breakpoint will be coming, after the destruction of chloramine, the breakpoint will be coming usually, right? So what is the breakpoint over here, guys? So breakpoint of chlorination is termed as it is that point at which the chlorine demand of water is met. The chlorine demand of water will be met actually at this point of time, right? You can say that that was the amount which was needed for this particular water. That amount of chlorine was needed for disinfection of this water, right? So actually breakpoint tells us about the demand of the water, right? The demand of the water, that how much demand is actually needed. So chlorine demand of water is actually estimated by the breakpoint, right? So I was talking about the the chlorine demand of water. I was talking about the chlorine demand of water. So simply, guys, just remember over here that it is the difference between the amount of chlorine, right, between the amount of chlorine which is added to water and amount of chlorine which is remaining at the end of specific period of contact, right? Specific period of contact, and generally this contact period is around 1 hour, that is around 60 minutes, right? So that is basically the chlorine demand. What is the breakpoint of the chlorination? One more point over here which I would like to mention. Breakpoint of the chlorination, however, we have already understood that the breakpoint of the chlorination is that it is that point at which the chlorine demand of water will be met, right? Chlorine demand of water is met. Okay, it is that point. Beyond this breaking point of chlorination, listen to me very carefully over here. Beyond this breaking point of chlorination, what you will be having in the water? You will be having the free residual chlorine and you will be having the combined residual chlorine as well. You will be having the free residual chlorine and the combined residual chlorine, and in total we will be calling that as total residual chlorine. Okay, so that is the thing over here. Once the chlorine demand of the water will be met, that point is called as the breakpoint of chlorination, right? Once we are clear with that, what about the contact period? Contact period of free chlorine is at least 60 minutes, right? Breakpoint. So over here I am saying that contact period of free chlorine. Okay, so free chlorine with the water, the time period over here, it should be around what? 60 minutes. Time period over here, it should be around 60 minutes, that is around 1 hour. So that's why I told you over here that the difference between amount of chlorine added to water and amount of chlorine remaining at the end of specific period of contact, that is called as the chlorine demand. Right, so I was talking about the breakpoint chlorination. Once we have understood about the breakpoint chlorination, I was talking about the contact period of the chlorine, residual chlorine, which was a free residual chlorine, right? So what we have talked, right, guys, I told you that after the breakpoint, we are having the formation of free residual chlorine and the combined residual chlorine. In total, we were calling that as total residual chlorine. So free residual chlorine, the contact period of free residual chlorine with the water should be at least around 60 minutes or 1 hour. to adequately kill the bacteria and the viruses in the water. So what we have understood that what about the contact period? What about the contact period? Contact period says that once the residual chlorine will be formed, once the free residual chlorine will be formed, there should be at least, right, 60 minutes are required. 60 minutes are required for the contact period of free residual chlorine, right? At least 60 minutes are required to kill bacteria and viruses in the water, right? Obviously in the water. That is the contact period. Okay, so I was talking about here that the free residual chlorine with the water, it needs the 60 minutes, and that will be called as the contact period. That will be called as the contact period, right? Okay, once you understood that, now we shall move on to the particular breakpoint chlorination. Once we have talked about this particular contact period, so let me summarize for you guys. Here I have told you that in the graph, first of all, we are having the formation of chloramine. Then we are having the destruction of the chloramine. Then the breakpoint comes. After the breakpoint, you are having the formation of some substances. What are those substances? They are the formation of free residual chlorine. There is a formation of combined chlorine compound, right? Combined residual chlorine. In total, we are calling that as total residual chlorine, right? There are two more important things over here, right? Along with that, we shall be having some free chlorine which will be evaporating after the breakpoint, right? Some free chlorine would be there, right? That will be there, which will be binding with the water, okay? And some amount of chlorine might be actually getting evaporated also. So that amount of free chlorine might be getting evaporating also. Some of the chlorine that might be actually mixed with the impurities as well, right? Some other kind of salt with that they can be actually mixed over there, right? So that is the thing which we had to talk about as far as breakpoint chlorination is concerned, right? Chloramine formation, chloramine destruction, breakpoint comes, free residual chlorine will be coming. Okay, that might be adding with the water. Some of the free residual chlorine that might be combining with the impurities. Some of the free residual chlorine that might be evaporating from the water. Some of the combined residual chlorine will be formed. Free residual chlorine which was binding with the water and the combined residual chlorine, they will be actually together called as the total residual chlorine, right? So how many things after the breakpoint, guys? I'm just writing, so that you are not forgetting anything. After the breakpoint, guys, after the breakpoint of chlorination, after the breakpoint, what things are actually we were getting? First of all, we were getting the free residual chlorine, right? Now, free residual chlorine, some of the free residual chlorine might be actually evaporating. Some of it might be actually mixing with water, and some of it might be mixing with some impurities, right? Along with that, we might be having, this was A, this is B, combined residual chlorine, right? And free plus combined, right? Free plus combined will be called as the total residual chlorine, right? Now I got the satisfaction that at least now you must have understood that what I'm talking about. I have talked about what till now? I've talked about the chlorination, chemical parameters of the water quality. I've talked about the chlorination of the water. Chlorination of the water, the importance is very, very high, guys. Chlorination of the water, over here, what we have understood. We have understood about the chlorination of water that we are having a breakpoint, something called as breakpoint of chlorination. Breakpoint of chlorination when it comes after the destruction of the chloramines. First of all, what happens is we are actually adding the chlorine to the water. At that point of time, in the water, we are having the microorganism that will be producing what? That will be producing the ammonia. The chlorine which we are adding to the water, it will be mixing up with the ammonia, and then it will be making the formation of, it will be actually causing the formation of chloramines. So in the first go, there is a formation of chloramines, and then if you will be keep on adding the chlorine to it, there will be the destruction of the chloramine, and then there is a breakpoint which is coming over there. After the breakpoint, there is a formation of free residual chlorine and the combined residual chlorine. Free residual chlorine might be, some of it might be mixing with water, some of it might be evaporating, some of it might be mixing with the impurities as well. Once we have talked about that, now I'm having some confidence to discuss about the Horrocks apparatus with you. So now let's talk about what is Horrocks apparatus, right? Very important one. Sometimes they are actually easing your job by just putting the picture over there in the exam, and you just need to identify the image, right? So this is the image which you can see right now on your front of your screen right now. This is the Horrocks apparatus. Here you are seeing some of the things over here. This is the Horrocks apparatus, right? The A image, this is the B image of the Horrocks apparatus. Here what we can see that in the first image we are seeing that same things over here. We are having this box. In the box we are having some glasses. One glass is having the black color, other glasses are the 6 glasses which are white in color, right? As you can see over here, we are having one black color glass over here, and other one are the 6 glasses. 1 2 3 4 5 and 6 glasses are there, and one starch iodide reagent is also present over there. This is starch iodide reagent, and some of the pipettes and some of the other things are present over there, right? So if you talk about the Horrocks apparatus, guys, what is the need for the Horrocks apparatus? First of all, it actually measures the chlorine demand in the water, right? It actually measures the chlorine demand. It measures chlorine demand in water, right? And that's why we need it. Okay, so how it measures chlorine demand in water? First of all, let me tell you what are the things which we are seeing in the Horrocks apparatus, right? So I've just inserted the image over here. However, it is blurred so that we don't waste our time in writing the stuffs. So over here, guys, we can see the Horrocks apparatus. It is actually used to find out the dose of bleaching powder required for the disinfection of the water, right? So over here in the Horrocks apparatus, we are carrying one black cup, which is actually having the capacity of around 200 ml. Then we are having the 6 white cups, which is having a capacity of around 200 ml again, right? So one black cup I told you, and other 6 cups, these are white in color, right? Then we are having 7 glass stirring rods in it, right? So sometimes why we are telling you all these kind of things, because generally very commonly they're asking us which of the following is not apparatus for the Horrocks apparatus, right? So for that particular thing you need to know about this one. So one black cup, 6 other white cups, 7 glass stirring rods, one pipette could be there, 2 droppers, and starch iodide indicator. What indicator we are using over here? Starch iodide. How many black cup is there? One black cup. How many white cups are there? 6 white cup. What is the volume of these cups? These are the 200 ml, right? Now then there is a bleaching powder, right? Then there is a bleaching powder for the disinfection of the water. 2 metal spoons will be there, which will be holding around 2 grams of bleaching powder, right? And then there could be the plastic or the wooden box container for all these items which will be carrying. For example, you are seeing that wooden box would be there for carrying all these particular items, right? 6 white cups we are seeing, and 1 black cup we are seeing. 1 black and 6 white. Okay, once we have understood that, now we shall talk about how we are actually performing this particular procedure, right? Now if you talk about the procedure, guys, we are seeing that first of all we need to take 1 spoon, right? In that 1 spoon we need to carry the 2 gram of bleaching powder, and we will be mixing it in the black cup. Very important. In the white cup or black cup? In the black cup you will be mixing 2 gram of with the spoon you will be mixing 2 gram of bleaching powder in the adequate amount of water. Okay, in just bit of water you will be mixing it in the black color cup, right? And then you will be making a paste out of it. After a paste, after making up the paste, you will be adding water to it. Water up to the circular mark which will be actually present in the black cup over there. With vigorous stirring you will be fill the water till that point of time. As you can see over here, after making that particular solution, after making the paste with the 2 gram bleaching powder, the water has been filled till the mark. The water has been filled till the mark, you can see over here, right? Water has been filled till the mark over there. Then what happened? You will be having 6 other white cups also. What you will be seeing that once you are making that solution, this solution is called as the stock solution, guys. This solution is called as the stock solution. Very important. Then you will be actually having the 6 white cups. You are having 1 black cup and 6 white cups. In the 6 white cup, what you will be doing? Fill all the 6 white cup with water to be tested. For example, you want to test the swimming pool water. So you will be filling up that particular water in the 6 cups 1 centimeter below the rim. Okay, the marking will be given over there. With special pipette, what you will be doing? 1 drop of stock solution which you have made in the black cup. Okay, you will be taking from the pipette the solution out of it, and then you will be adding 1 drop of it to the first cup. 1 drop of it to the first cup. Let's say this is the first cup over here, this is the first cup, this is the second cup, this is the third cup, like that. So 1 drop in the first cup, 2 drops in the second cup, 3 drops in the third, 4 drops in the fourth one, 5 drops in the fifth one, and 6 drops in the sixth one. Very simple. Okay, whatever the number is there, that much drops you will be putting in over there, right? So 1 drop, 2 drop, 3 drop according to the number. As you can see, 1 drop of stock solution to the first cup, 2 drops to the second cup, 3 drops to the third cup, and so on and so on. Okay, and so on and so forth. And sixth cup will be carrying how many drops? 6 drops. Each cup, okay, stir each cup and separate the rod and wait for around half an hour. Okay, after that, what you need to do? Wait for 30 minutes. Wait for 30 minutes. Then you will be adding the 3 drops of starch iodide solution, which I was saying that it is the reagent. What is the reagent over here? The reagent is the starch iodide solution. That is also the MCQ over here, guys. Please do remember that. To each white cup, okay, you will be adding the 3 drops of starch iodide again. And then, you know, there is the development of bluish kind of color. There is development of greenish bluish kind of color right over there. Whichever white container is showing you the blue color first, right? Whichever container, which will be showing you the blue color first, will be estimated as that it is this particular cup will be having the residual chlorine. This particular cup is having the free residual chlorine. Now what will you do? For example, there was a third cup which was showing this particular color first, blue color, right? Third cup started showing the blue color. Let's say after all of these things, third cup started showing the blue color, right? Let's say it is showing the blue color, right? Now what you will be doing, actually there is a formula for that. You know, you will be actually what you will be doing over here, you will be having the formula of N into 2 grams. So here, let's say third cup started to showing that blue color. So here the formula will become 3 into 2. It will be 6 grams of bleaching powder that has to be added into to disinfect the 455 liters of water, right? Sometimes they might be asking you that this much liter of water is there. So how much gram of bleaching powder needs to be it has to be needing, right, to disinfect this particular amount of water, right? So at that point of time, you just need to apply this formula. So N into 2. So whatever, let's say the fourth cup started to showing the black color. Sorry, started to showing the blue color. So what will be doing? N into 2. So that is the fourth cup started to show it first. So 4 multiplied by 2, that will become 8 grams, right? 8 grams for 455 liter of water. So whatever amount of water is given, you will be doing the calculation, right? So that is the thing. So N into 2 will be needed for 455 liter of water. That is very important. You need to remember this. Okay, so once we are clear with that, that is about the Horrocks apparatus, right? Now we shall move on to some methods of the chlorination, right? The methods of the chlorination, some of the methods I'm just mentioning over here. So now we shall talk about some methods of chlorination, right? Some methods of chlorination, okay? If we talk about some methods of chlorination, here we are having important 3 methods I will be telling you over here. So first one which I am saying, that is the bleaching powder, right? Second one which I will be talking about, that is the perchlorone, okay, perchlorone. And the third one is the chlorine gas. Third one is the chlorine gas. So let's talk about them as well. If we talk about the bleaching powder, guys, here it is containing the sodium hypochlorite, and it gives for around 33% of free chlorine. It gives around 33% of free chlorine, 33% of free chlorine, right? If we talk about the perchlorone is carrying the calcium hypochlorite. So please do remember them as well, calcium hypochlorite. And over here it is giving around 66%. It gives 66% of free chlorine, okay? And if you talk about the chlorine gas, it is actually having a special color, you know, amber color or the yellow color. Amber or yellow cylinders are present over there, okay? That is giving for around 100% of the free chlorine, okay? And that might be asked, which of the following method of chlorination is giving the 100% of free chlorine? That is your chlorine gas, free chlorine, okay? So very, very important, guys, for the exam purpose. Now we shall talk about some of the methods for the levels of chlorine estimation, right? So chlorine levels might be estimated by these particular methods, right? So if we talk about the chlorine levels estimation, so let's talk about the chlorine levels estimation now. In the chlorine level estimation, we are having two important methods, right? One is the orthotoluidine test, and another one is the modification of this test, that is the orthotoluidine arsenide test. So let's talk about the very first one first of all, that is the orthotoluidine test. Orthotoluidine, or it is also called as the OT test. Orthotoluidine test, basically, you need to remember. If we talk about orthotoluidine test, right here, remember after the breakpoint what was happening? After the breakpoint, I told you that there was a formation of free residual chlorine, there was a formation of combined residual chlorine, there was a formation of total residual chlorine, right? All of these things. So over here, this is the method, orthotoluidine test. It will be actually helping us in determining the free and the combined residual chlorine accurately and rapidly. But the problem over here is that, this particular method we are using, but it is actually giving us the both values, not separately, but the combinedly. So it is actually helping us in determines free and combined residual chlorine in water. Residual chlorine in water rapidly and accurately. Okay, rapidly as well as accurately, right? But what I told you over here, there is a drawback over here. The drawback is that it is not telling us that this much amount of free residual chlorine and this much amount of combined. It is actually telling us that both of these agents are present in this much, right? So that is the thing over here. Now then we came to know about one more method. This is the modification of this method, that was the orthotoluidine arsenide test. That was telling us separately that this much amount of free residual chlorine is there and this much amount of combined residual chlorine is there, right? Anyways, the reagent which we were using over here in the orthotoluidine test, the reagent which is needed for over here, so the reagent for this test is the analytical grade orthotoluidine, right? And we will be actually mixing it with the 10% of the hydrochloride solution. Okay, we'll be mixing it in 10% of HCl solution. Okay, that is very important. Now next thing over here is that what we are doing basically in this particular thing, what we are doing, there is a chlorinated water. Okay, we'll be adding this to this particular solution, right? We'll be adding to it. After adding to it, what will happen? It will be start showing us the yellow color, right? So once the chlorinated water, right, what I'm saying is the chlorinated water will be added to it, right? Chlorinated water will be added to this particular, let's say it is the solution, chlorinated water will be added to this. After this, it will be showing the yellow color, right? So it will be showing us the yellow color. Right now, there might be two possibilities over here. One possibility is that it will be showing the yellow color slowly, right? It might be showing yellow color slowly, or it might be showing yellow color rapidly, right? If it is showing us this particular color, that is this particular color, that is yellow color, if it is showing slowly after the addition to the chlorinated water, then we'll be saying that it is the combined chlorine. And if it is showing the yellow color rapidly, then we'll be saying that it is the free chlorine which is present, right? So if it is showing this color rapidly, then we'll be saying that it is the free chlorine which is present over there. It is the free chlorine which is present. It is a free chlorine which is present, right? And if it is showing slowly, this yellow color, if it is showing slowly, then we will be saying that this is actually the combined chlorine which is present in the water, right? So what I'm talking about? I'm talking about which test? I'm talking about the orthotoluidine test. Why I'm talking about this test? Because this test is actually determining what? It was determining the free as well as the combined residual chlorine, right? Now, how we are saying that it will be showing the free and the residual combined chlorine? We'll be adding it to the which water? Chlorinated water, right? We did the chlorination of the water. right? Remember, and I told you that after the breakpoint, what was happening? Free residual chlorine, combined residual chlorine. So what method we are using for estimating that? This particular method, that is the orthotoluidine test, right? If it is after the addition of this particular solution, that is what is the reagent? Orthotoluidine, analytical grade orthotoluidine. We will be mixing it with the 10% of hydrochloride solution, and then we'll be mixing it with the chlorinated water. After that, it will be start showing us the yellow color. If it is start showing us the yellow color rapidly, then we'll be saying this is the free residual chlorine. And if it is start showing the yellow color slowly, then we will be saying that this is the combined residual chlorine in the water. I hope you understood that. Now I'm coming to the next test, that is the modification of this test only, and this test is called as the orthotoluidine arsenite test. Second test over here which we shall talk about, that is the orthotoluidine arsenite test. Orthotoluidine arsenite test, right? Here what we are talking about in the orthotoluidine, first of all, this is the modification of our previous test only. Modification of orthotoluidine test. Modification of what? Modification of orthotoluidine test only. Here what we are seeing, right? It is nothing but, it is telling us about the free residual chlorine and combined residual chlorine that orthotoluidine was also telling us about. Then what's new in this particular test? Actually, it is telling us that separately, that orthotoluidine test was not telling us the results separately, but actually it was telling us the results combinedly, right? Here we are saying that because it is nullifying errors. It is nullifying errors. How it is nullifying the errors? It is nullifying errors due to the presence of the substances like iron, nitrates, right, and manganese in it. Iron, nitrates, and manganese in it. Due to the presence of these ions, it is actually, due to the presence of these substances, it is actually nullifying the errors. And that's why we shall say, at last we shall say that this particular thing, that this orthotoluidine arsenite test, which is also called as the OTA test, right? This is actually determining us, helping us actually in determines what? Free and combined chlorine separately. Free and combined residual chlorine separately, right? And we are doing that with the help of chloroscope or chlorometer. Chlorimeter or chloroscope, you can see the image over here. This is the chloroscope, right? This is the chloroscope over here, right? And with the help of this chloroscope, we are actually, this particular thing is actually helping us in estimating the levels of chlorine, right? So what we have talked about, orthotoluidine test and the orthotoluidine arsenite test, right?